In this video, I'm going to show you how to make a standard edition Gran's plot for our acid snow titration. Here's the blank worksheet. I filled in some data. I filled in my volumes for the titration, and I'm always going to fill in this first point where I haven't added any sodium hydroxide yet. The pH there is going to be the pHi that I'm going to need, the initial pH that I'm going to need to calculate the Gran's function. But I will not include that first point on my graph. I am only going to include points that are between pH 3.5 and 4.5. So I've done that with both of the curves. This one is the blank titration, this one is the snow titration. All right, so the first thing I have to do is calculate the Gran's function. In the write-up for this, you've got the Gran's function format here. This is the volume of sodium hydroxide added. This is the initial volume before you add any sodium hydroxide. That initial volume is going to be the volume of the, in the blank titration, it'll be the 100 milliliters of DI water plus the 5 milliliters of added 0.005 molar H2SO4. So it'll be 105 milliliters. That's what VI is going to be. And the initial pH is the pH that you have before you add any NaOH. So this would be pHi for the blank titration. This would be pHi for the snow titration. And then the pH is the pH that you're reading off the meter at volume V. All right, so let's calculate the Gran's functions really quick. I'm going to put in a Excel function here, equals, now I want it to be the volume plus the initial volume. Now, I want, when I drag this down to calculate it for all the other points, I do not want it to drag down the VI. I want it always to take the VI from that same cell. So I'm going to put dollar signs into the cell reference for that to keep it from sliding down when I drag this cell. Times, and I'm following this formula over here, 10 to the, I'm going to need some parentheses here, the initial pH, and I want that not to drag down. I want to freeze the reference to that cell, so it's taking pHi from the same place every time, minus the pH I have at volume V. So that should give me the Gran's function for the first cell, and that's correct. And now I can drag this down and calculate the Gran's functions for all of the other cells there. Let's do the same thing over here for the snow titration. It's going to be the volume plus the initial volume, and I have to freeze the cell reference to that, times 10 to the initial pH is this. I need to freeze the cell reference for that, minus the pH at that volume. And I've got the same Gran function here, and I'm going to just drag that down. And now I have the Gran's functions computed, so I am ready to make the graph. Now if I scroll down, it shows me where it wants me to put the graph. Let's put it here for originally, and then we'll drag it down there. It wants you to put title, labels, a legend, and trend lines on there. So let's do that. I'm going to go up to, I'm going to click off this. I don't want anything selected before I insert the graph. I'm going to go to Insert on the ribbon, and I'm going to come down to Charts, and I am going to insert an XY scatter chart like this. All right, so I originally get this blank square here, and now I want to add some data to that. I'm going to right-click on this, or pop up on this, and I'm going to choose Select Data. Now it gives me a little form where I can add curves. I'm going to add two curves here. I'm going to add one for the blank titration and one for the snow titration. So I'm going to say Add. And let's label these. This will be the blank titration. And the x values are going to be here. And notice that I did not select that first one because I only want points with pHs between 3.5 and 4.5 on my graph. And then I am going to go select the y values. The y values are not the pHs, they're the Gran's functions here that we just calculated. And again, I leave that first one off because it's not in the pH range I want. And I'm going to say OK, and I should see something like this. Now let's add the snow titration. Add. I'm going to call this the snow titration. And I'm going to add the x values on here. And I'm going to leave off that first one because it's not in my pH range, 3.5 to 4.5. And then I am going to go and select the Gran's functions that are in that same range. So I'm going to start here and drag down to here. And it should put the snow titration in. And notice I get a second curve in there. Okay, fine. I'm going to say OK, because that looks pretty much like what I want. I don't have axis labels and a title or anything on this, so the next thing I'm going to do is go up here to Quick Layout, and I'm going to pick this default layout. You can always pick this first one here. That has everything that we need in it. And just for now, I'm going to make this a little bigger, so maybe it's a little easier to see what's going on. And I'm going to fit trend lines to these two now. Okay, so this one's the blank titration. If I click on one of the points, they all light up. And I'm going to right click on this or pop up on this, and I am going to get add trend line on the pop-up menu. So when I do, notice there's some stuff that appears over here. It wants me to fit a line. That's fine. I would kind of like to see where this line hits the x-axis. So I think I'm going to forecast it forward. I don't know. Where's it going to hit? Probably 2 units ahead or something. Let's try that. And I'm going to try and display the equation for this on the chart. Okay, so 2 units ahead went a little too far. Maybe I'll put 1.5 there and see what happens. I can see where it is intersecting, but maybe a little bit less than that, 1.4. So that's kind of a trial and error thing. I also want to show this r squared value on the chart. We're going to see later when we do regression statistics that the r squared value tells you what fraction of the variation in the data is explained by your model, which is this line here. And that r squared value is telling us about 99.89% of the variation in the data is explained by our linear fit. I can go in here now and I can label this. This is the blank titration. I just want to make it absolutely clear which titration I'm looking at. Okay, and I can drag this around. I'm going to put it close to that line. Let's do the same thing for the snow titration. I'm going to click on the points. I'm going to pop up a menu by right-clicking. I'm going to say Add Trend Line. I want to see this trend line where it hits the x-axis, kind of. So I'm going to forecast it forward, what, maybe 1? I'm going to display the equation on the chart and display the r squared value. It's down here where I can't really read it, so I'm going to drag it up here. That's okay. I mean, I could have forecasted a little bit less, and then I wouldn't have this ugliness down here. If I want to get back to formatting the trend line, I can just click on the trend line again, and I'm back to that. So maybe I'll go a little bit less forward. Maybe that far, even a little less than that, maybe 0.7. And that way, well, I can see where it hits the x-axis, which is really the important thing. Let's label this snow titration so we can see it. All right, and let's pretty up the graph. Let's put a title in here. This is a standard addition Gran's plot. for acidity of a snow sample. And let's label the axes. The x-axis is milliliters of NaOH added, and the y-axis is the Gran's function. Okay, and then that's ready to go. I can drag that down into the space where it's asking for the Gran's function. And let's resize it a little bit. You can grab the handles on the end and drag it around so it's not covering up anything important. Okay, now down here, it wants you to put the slope and the intercept for each of these titrations in here. You could just type these numbers in here, but let me show you another way to do it. There's a slope function, equals slope. And then if I select the known y's, comma, known x's, it'll calculate the slope and put it in there. And it ought to be the same thing for the blank titration as that minus 18.917. But let's go up here, select the known y's, which are the g's. I'm not selecting that first one because it's out of our range. And then I'm going to say comma, and then I'm going to select the known x's, which are the volumes here. And I'm going to close the parentheses. And notice it put in the number that I have up there, except it didn't round it off. So the way I'm doing it is a better way to do it. I can do the same thing for the snow titration. Known y's go first, then known x's. Close the parentheses. And I've got the slopes in there. Let's put the intercepts in there. There is an intercept function, intercept, which is the known y's. Whoops, let's do this one. Comma, known x's. And the intercept for this one is going to be the known y's, comma, the known x's. Okay, fine. And if I look up here, I can see that those are the same numbers. Now, the endpoint is going to be the x-intercept, the point where the line hits the x-axis. I'm not going to just crudely read it off here. I'm going to solve the equation 0 equals mx plus b for x. So that works out to be equal to minus the intercept divided by the slope. And there's where it is. And I can see that does hit around 5.8 milliliters there. I can drag this down and just do it for the other curve that simply. Now, the milliliters of sodium hydroxide required to neutralize all of the hydrogen in the snow is going to be the difference between these two endpoints. So I'm going to say it's equal to this one minus this one. Okay, so there's my endpoint. Now let's change that to an acidity. I'm going to take that many milliliters of NaOH. I'm going to change it into liters. Now it's in liters. And then I am going to multiply liters that I have here by moles per liter to get moles of NaOH. So I have to go up to the molarity of my NaOH solution there. And then I would turn moles of NaOH into moles of H+, but it's a 1-to-1 ratio, so I don't have to really type anything there. And that's going to be the acidity of snow as a molarity. Now I can calculate it as milligrams of calcium carbonate per liter. That's going to be equal to this molarity. Okay, so I'm going to multiply that by, there's 1 mole of calcium carbonate for every 2 moles of H+. So that turns into moles of calcium carbonate. And then I'm going to multiply it by the molar mass. There are 100.0869 grams of calcium carbonate per mole.